Chapter 1 was on three concepts: line symmetry, rotational symmetry, and composite areas. The test you wrote here that we're going to correct today was made up of both the chapter review and the practice test from the actual textbook. I extrapolated all of the questions and made various similar questions for your test-taking pleasure. Question 1 and 2 and 3 and 4 are all true and false. It says a rectangle has 4 lines of symmetry. So a rectangle has, it says, 1 line of vertical symmetry, 1 line of horizontal symmetry, and 2 lines of oblique symmetry. Well, the answer is false. And the reason why is it doesn't have oblique. And we said this because when we studied the rectangle, what happens when I reflect a rectangle obliquely? It makes a kite, doesn't it? So if you were to take this rectangle and cut it down the middle here and reflect this part here, it would actually end up forming a kite because this point would be here across that line of reflection, right? So the answer is false. It doesn't have any oblique lines of symmetry. Question 2, this object has 1 line of symmetry. The answer is true. Because it's a square, and because that plus sign is located there, it does have 1 line of oblique symmetry. And all you needed to do to prove it was just draw that line there, or write true, it has oblique symmetry, 1 line. Order 1 rotation is the same as no rotational symmetry. The answer for that is true. If I drew a happy face and took that happy face and rotated it, it does not appear as itself until the very end, which means the order of rotation is 1, and it did not appear as itself as it started, so therefore it is the same as having no rotational symmetry. And finally, this object has rotational symmetry and line symmetry. The answer is false. You cannot put a line anywhere where the reflected half will be identical to the other half because of the colors. Correct? So therefore the answer is false. It has no symmetry, both line or rotation. I'm sorry, it does have rotational symmetry. It does not have line symmetry. I think that's what we said. Is that what we said? Yeah, something like that. Question 5 was an absolute disaster. And the disaster should have been avoided because I told you it was going to be on the test, right? I told you, I gave you an example on the Google Classroom and showed you this is going to be on your test. I wrote it in big capital letters, and people just disregarded it like I was crazy. So a cube is 10 by 10 by 10, which means this is 10, this is 10, and this is 10. And the square hole here is 2 by 2. So if you drew it like that, that would be the appropriate numbers in the appropriate spaces. What would be the surface area of a cube where no holes were taken? 6 sides squared. I had like 6 people tell me it was side cubed. We're not asking for the volume of the cube. We're asking for the surface area. So without a hole, that is the formula for the entire shape. However, what's missing from the surface is this opening here, and over on the other side, the square that we can't see over there. So 2 squares are missing. How do I write 2 missing squares mathematically? Minus 2s squared. That's minusing 2 squares. But inside, there's a hole, and we have these rectangles. How many of those rectangles exist inside that hole? 4 of them. How do we say adding 4 rectangles? We say plus 4LW. Now that formula was worth 2 points, right? I would have half the people in this room not write that formula properly, but I allowed for variations that were semi-acceptable. But that is not complicated, especially because the practice question I gave you online was identical, right? No excuses. Once we substitute it, since the side length here of the larger cube is 10, I substitute it like that, minus 2 smaller squares plus 4 rectangles. Now, what's this width here? It's 2. And what's the other length? It's 10. Right? It's the same measurement as this because it goes all the way through. Now that we have our substitutions, simplify. Exponents first. Multiplication second. And your final answer will be 672 square centimeters of surface area. Oh, sorry, 572. 570, no, 672. 672, yeah. It wasn't, was there any excuse to be off with anything? It wasn't a complicated question, I didn't think, was it? Obviously, when you see it, you're like, yeah, that wasn't so hard. I guess I could have done that. But it was worth, how many points was that worth? It was worth 7 points? 8 points. It was worth 8 points. And as long as you were able to demonstrate some competency with area, you got some variation of that 8. Question 6 was a disaster for some. A complete and utter disaster. I'm going to use a pretty red line. I'm going to make a little red line here. Just, can I make it red? Let's make it red. And that will be, oh, hang on. That'll be our line of symmetry. So we'll talk about line symmetry first, horizontal symmetry, so up and down, vertical symmetry first. We'll do vertical. Does A have vertical symmetry? So A goes here. Does B? Hang on. No. Does C, D, E, F, G, H? Yes. H. Marker falls on floor. H is there. What about I? Yes, it does. Beautiful symmetry, actually. What about J, K, L? How about M? Yes, it's beautiful. How about N? O? Oh my. P? I can't grab it. There we go. P, Q, R, S, T. Yes. How about U? Uh-oh. Abandoned ship. U does. What about V? What about W? What about X? What about Y? So U, V, W, X, Y. U, V, W, X, Y. Those are all of the letters that contain vertical symmetry. If you had extra ones in there, you lost a point. If you forgot one, you lost a point. Right? But those are the, how many is there? 10? 1, 2, 3, 4, 5, 6, 11 of them there. Okay? Now, when we talk about horizontal symmetry, we're talking about symmetry the other direction, right? We're talking about this way. So if I grab this, does A have horizontal symmetry? What about B? B does. Yes, it certainly does. And not this one, it doesn't. The one in the textbook did. The one I wrote here, it does not. It's a 6. It is. Who says yes? How about C? How about D? How about E? Are you sure? It does have. This one does. This is equal spaces on both if you look at it. The one in the textbook didn't, but this one did. What about G? What about H? Actually, you know what? I got a better idea. I got a great idea. Oh, not that though. I'm going to put it here. Look at that. Let's look at it this way. E, what about F? No. G, no. H does. I, yes. J, no. What about K? It does not. You look. Where does... All right, we have argued the point. K does. I made a mistake. Did you have that one? You get an extra point. We're rolling with it. What about L? No. M, no. N, no. What about O? O does. What about P? Q, R, S, T, U, V, W, X does. Y does not, and Z does not. So B, X, E, H, I, K, O, X are all of the letters that have horizontal symmetry. Now here's where the poop hits the fan. Oblique symmetry. Oblique symmetry. There is... Okay, we're back. Here's the problem. None of these objects have oblique symmetry. O is not a circle. O is a, this is it. I copied this. This is the letters from the test. O is an oval, in which case, if you cut it this way, it's going to look like this. Most of you. Any other letters were thought? None of them. X is a rectangle. Correct. So those are all the letters that we were accepting. None for oblique symmetry. None of them have it. Now, rotational symmetry. If it appears as itself upside down as it did at the start, then you're good. This does not, 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 this does, this does, this doesn't, this doesn't, this doesn't, this doesn't, this does, this does, doesn't. How many say does? S. Turn your paper upside down. Turn your paper upside down. Is that the same as it was right side up? It's slightly larger on the bottom, isn't it? So S does not. T doesn't, U doesn't, V doesn't, W doesn't, X does, Y doesn't, and Z does. So your answers for rotational symmetry were H, I, N, O, X, Z. And obviously the rest didn't matter because they all count. Question 7, how many lines of symmetry are there? And tell me which types it has. So yes, it has vertical, horizontal, oblique, 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 and oblique. So your answer is 6 lines. It has 4 oblique, 1 vertical, 1 horizontal. Now the interesting thing is, this has no line symmetry because you can't cut it in half where the reflected image is the same as before. So it just has no line symmetry. Each one of those was worth 2 points. Question 8 was supposed to be the easiest question on the test, but some of you went and made it all complicated. If this notch is missing, what we talked about was, does it affect the volume of the rectangular prism? Yes, it's smaller volume. Does it affect the surface area? No. So we can treat it like it was if it was just itself. So therefore, 2 tops and bottoms, 2 left and right, 2 front and back, or 2 12x7s and 2 5x7s and 2 12x5s. When you work this out, what's that become? 84, 168, 35, 70, 60 and 12, 120. That's 220, 288, 328, what is it? 358. Formula, substitute, simplify, solve. That's all you had to do. Wasn't complicated. That was worth 5 points for that question. 6 points for that question, sorry. The next question, 9, says what's the order of rotation and the angle of rotation? So the order of rotation, how many appears as itself? So it's once, twice, 3 times, 4 times, 5 times, 6 times in one rotation. So the order is 6. And the angle is 360 divided by 6, or 60 degrees. The number 6199 appears itself only once, twice. So the order is 2, and the angle is 180 degrees. 2 points for each of those questions. That should have been an easy 4 points for everybody. Question 10 was shocking. Shocking. Here's how I did it on my test. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, hang on. I didn't do it like that. I did 1, 2, 3, 4, 5, 6. Is there any other side that has 6? The back. So the front and back is 6 and 6, which is 12. Now I'll take a different color. Top. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there any one that has 9? The bottom. So the top and bottom is 18. And then 1, 2, 3, 4. Is there anyone that has the other 4? So that's 8 for the left and right. Add those together. You get 38. This one. Let's do the top and bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. The bottom is also 9. So top and bottom is 18. 1, 2, 3, 4, 5, 6, 7. The other side has 7, so we're going to go front and back. Is 14. 1, 2, 3, 4, 5. There's 5 on the other side, so left and right is 10. Add those together, you get 42. Which one is larger? Object B has more surface area. But then this was the other part. How much more does it have? It has 4 more. More. That's all you had to write. Something silly like that. And that question was worth 5 points. 2 points for 38, 2 points for 42, and 2 points for it has 4 centimeters squared more. And our last question is our definitions. A type of symmetry is line symmetry. D, what you are measuring when you find the area of all the faces, which is your surface area. The amount of a turn is your C, angle of rotation. 14 is F, the order of rotation, then B, then E. Each one of those worth 1 point for a total of 6 for your definitions. Overall, the test was worth 65 points.